Hello guys, welcome back to my YouTube channel. In this video, I will be talking about the kinematic equations. Let's get into the video. So, what are the kinematic equations? Kinematics is the study of motion of objects without reference to the forces that cause a motion. So this is a topic in physics, and it's very important because a lot of physics is all about motion. So there are four kinematic equations, and they are V final is equal to v initial plus acceleration into time. Change of x, which is the distance traveled, is equal to initial velocity into time plus half acceleration times squared. Distance is equal to final velocity plus initial velocity divided by 2 into time. And final velocity squared is equal to initial velocity squared plus 2 times acceleration times distance squared, times distance. However, before we talk about these equations, let me introduce all the components of the equations above. So, what is v final and v initial? Velocity is the speed at which an object is traveling in a given direction. V initial is the initial velocity of an object, and v final is the final velocity of an object. The SI unit for velocity is measured in meters per second. So initial velocity, meaning this was the velocity that the object started at, and final velocity is the velocity at which the object stopped at. What is acceleration? So acceleration is the change in velocity over time. Acceleration can be both positive, meaning the object is gaining speed, and it can be negative, which means it's losing speed. The SI unit of acceleration is meters per second squared. So this is how you would see it in like a quiz or on a paper. What is t? So t is the total time interval for an object in motion. The SI unit of time is measured in seconds. Alright, but before we continue, I want to say that it's measured in seconds, but sometimes for longer durations of time, maybe like if you're on a plane traveling, then it would not really be measured in seconds, it would be measured in hours. What is change of x? So change of x is the distance an object traveled. Distance is the change in position of an object in unit time. The SI unit of distance is measured in meters. Now, distance also can be positive or negative. So how can distance be positive? Well, people generally assume if an object is going to the right or going upwards, then that is positive. So in that case, distance is also positive. For distance to be negative, it needs to be going to the left or downwards. So now I have went over all of the components of the kinematic equation, so this is just a quick overview. So for the first one, final velocity is equal to the initial velocity plus acceleration times time. Total distance traveled is equal to initial velocity times time plus half of acceleration times times squared. It's kind of a tongue twister. Total distance traveled is equal to final velocity plus initial velocity divided by 2 times time. So since there's a parentheses, this means that the t is distributed. And the last one here, it's final velocity squared is equal to initial velocity squared plus 2 times acceleration into total distance traveled. Okay, so now let's do some practice problems. So this will help you see how these questions are done. So practice problem number 1. An object starts at 15 meters per second. It goes for 2 seconds with an acceleration of 5 meters per second squared. What is the final velocity? So this is how you solve these questions. So now these are like multi-step questions, so you would want to write it down. You can't do all of this inside your head. So step 1, list all the components. You want to have everything right in front of you. So initial velocity is equal to 15 meters per second. T is equal to 2 seconds. And A, which is acceleration, is equal to 5 meters per second squared. Step 2, out of the 4, find the appropriate equation. And so what are the 4 equations? These are the 4 equations. So for this question, find the appropriate equation. So we are given initial velocity acceleration, and time. So we're asked for the final velocity. So here we have the initial velocity, acceleration, and time, and here's the final velocity. This is the perfect equation. Now step 3, solve. So final velocity, so input 15 meters per second over here. So 15 meters per second plus 2 seconds, which is 2 seconds, which is the time, into 3 meters per second per second. So acceleration can be written as this. So it can be written this way, or it can be written as this. It's the same thing. So final velocity is equal to 15 meters per second plus 6 meters per second, which on the bottom left corner is 20. So final velocity is equal to 21 meters per second. Practice problem number 2. An object starts at rest and stops at 30 meters per second. It's traveled for 10 seconds. So when you see something says an object starts at rest, so just assume that initial velocity is equal to 0. So step 1, list all the components. Initial velocity is equal to 0 meters per second, and final velocity is equal to 30 meters per second, and t is 10 seconds. Out of the 4, find the appropriate equation, and this is the perfect one that you would use. We have distance, which we have to find. We have the final velocity, we have the initial velocity, and we have time. Now solve. So distance is equal to 30 meters per second divided by 2 into 10, which is 15 meters per second into 10 seconds, which gives us a grand total of 150 meters. Last question. So the initial velocity of an object is 2 meters per second. The acceleration is 15 meters per second squared, and the time it traveled is 10 seconds. What is the distance traveled? So list all the components. Initial velocity is equal to 2 meters per second. Acceleration is 15 meters per second squared, and t is equal to 10 seconds. Out of the 4, find the appropriate equation. So change of x is equal to initial velocity into time plus half into a, acceleration, t squared. This seems to be the perfect one. Once again, like you would always do, solve it. So distance is equal to 2 meters per second into 10 seconds plus 0.5 of acceleration, which is 15 meters per second squared into 10 seconds. So that would give us distance is equal to 20 meters plus 75 meters. So grand total, we have distance is equal to 75 meters. So before I end off this video, I would just like to say that sometimes seeing all of this stuff like the seconds, meters per second, this could be a bit of a nuisance. So what people tell you to do is forget the unit. Just solve the equation as if there were no like units, and just add it up and find the appropriate SI unit. So if you recall that the SI unit for distance is only meters, so just solve all of this and just put meters at the end. So yeah, that is the video. I hope you enjoyed. Please like, subscribe, and I'll see you in the next one.